So in the first one, we have f of x equals 2. So what is this number 2? X or y? Y. So we are given y equals 2. We need to find what are the x's. So y is 2 here. So if you look at this line, how many x do you see in this line? 2. What are they? X equals 1 and 5. It is 1 and 5. Perfect. This is 1 and this is 5. Now this says find f of 3. What does that mean? What is given here? X. So when x is 3, what's the y value? So 1, 2, 3, you go to the y value, it's on the bottom, which is -2. So your y is -2. Now, who got all of them? Both of them, the 3. Wonderful. Great. So it was easy, right? As I said, easy question. Now let's see, what do we have for today's lecture? So last week we went over slope. To find the slope with 2 points is the slope formula. To graph, then use x-intercept, y-intercept, plot them. To find the slope from an equation, you solve for y, or it's simply negative a over b. Parallel lines have same slope. Perpendicular line have completely opposite, means opposite sign, and reciprocal fraction. Then we found the equation of the parallel line or the perpendicular line. And I think that's all, right? No, and then we did graphing, finding x and y. And then now we are going to do transformation. Transformation means use the original graph to graph the new equation. You don't have to do any math or any type of work. Just observe the original graph and see how the original graph has changed to the new version of the graph. So in this class, we are going to learn about 3 types of transformation: vertical reflection, then vertical transformation, and horizontal transformation. Reflection, when I say reflection, basically it means we are reflecting about the x-axis. So if you have a negative sign in front of the original function, all you have to do is reflect about the x-axis. For example, if we have y equals negative x squared, basically it means take the x squared graph, which is a parabola, and reflect it about the x-axis. So let's make it upside down. So if you have a negative in front of the original function, it's just reflection about x-axis. The second type is particle shifting. It means you are moving either upward or downward. How do you know when to do that? When you see the original function, and then you have a number plus and a number minus. The original function plus some number means you take the original graph and move it upward. But if you have the original function and then minus a number, you're taking the original graph and shifting it downward. So original function and then a number means either upward or downward. For example, here, we have x squared, this is our original function. After the x squared, we have plus 2. It means take your x squared graph, take the parabola, and then move it 2 units up. In this example, you take your x squared graph, which is a parabola, and you go 2 units down. So the original parabola is at the origin. For the top one, you move 2 units up. For the bottom one, you take the same parabola, move 2 units down from the origin. Then we have horizontal shifting. It's for horizontal shifting because you're going to go either left or the right. And when you do horizontal shifting, this is the weird shifting or bad shifting. This is bad. Why? Because it doesn't listen to the direction. When you go upward or downward, plus means up, minus means down. And it follows the y-axis. On the y-axis, the up part is plus and the bottom part is minus, right? Plus y is on the top, minus on the bottom. So it follows the direction. This is a good shifting. Here on the number line, we're supposed to go minus on the left, plus on the right, right? We have -1, -2, -2 on the left side, +1, +2, +2 on the right. So it's supposed to follow the direction, but it doesn't. If you have the original function, and inside the original function, you have a plus c, it's supposed to go on the right, but it doesn't. It goes on the left side because it's inside your function. Similarly, inside the function, if you have a minus number, it's supposed to go minus means left, but you don't. You have to go to your right. So the left-right shifting or left-right transformation is the bad one. It doesn't listen to your direction. For example, here, our original graph is x squared. Now inside the square, we have a +2. So x + 2, and then whole thing get the square. So the +2 is inside your function, inside the square. The +2 means it's supposed to go 2 units to the right because inside the function. But it doesn't go right. It goes 2 units to the left. Okay, that. Similarly, inside your square, you have -2. So x - 2, whole thing at the square. Now, since your -2 is inside, it can only go either left or right. -2 means it's supposed to go to the left because number line has number line has negative numbers on the left. So it should go to the left, but it doesn't. It goes to the right 2 units. So reflection means just flip it. Function and then a number, if it's plus, go up, minus, go down. But if you have a number inside your original function, then you have to go left, right with opposite direction. 3 types of transformation, and that's it. Any question? Great. Now, there are 4 types of original graph you have to remember in this class. These are the 4 types of original graph without any transformation. We call them parent graph. They're parent. They produce child, but they are the original ones. The first one is x squared. We call it parabola. The original x squared graph is a parabola at the origin. So this is x, this is y. So anytime you see any transformation with the square, that means you're taking this parabola, moving left, right, or up, down. The second type is cubic function. Cubic. Because it's a cube power. And yes, you have to memorize all these 4 shapes. The original cubic without any transformation is this graph. The right side goes up, the left side goes down. This is the original cubic function. X cubed. So this is x, this is y. The third type is square root function. This is x, this is y. I also do the same thing here. This is x, this is y. Square root function starts from 0, goes up little by little. So slowly it goes upward. This is square root function. Lastly, we call it absolute value function. Absolute value. Do you know the shape of absolute value function? Good job. It's a V, victory. It's a V at the origin. This is absolute value function. So you must remember all four shapes. In the exam, there'll be at least one of these with transformation. Okay, so these are the four parents graph. We call them parents. Some people call them something different, I forgot. But I just remember parents. These are the four parents graph. Ah, let me rewrite nicely. Parents. Now we are going to do transformation based on these original graph. The first transformation is reflection. It means you have all the original graph, all the original function, but in front of the function, you have a negative sign. So we have original graph is x squared. For reflection, we have negative x squared. The original graph is cube, x cube. For reflection, we have negative x cube. The original graph is square root of x. Its reflection is negative square root of x. The original is absolute value of x. Its reflection is negative absolute value of x. So the same graph, the parent one, but in front of parent one, there's a negative sign. It means you have to reflect about x-axis. So let's draw all of this. Let me change the color. Y. 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 When you do transformation, it's better to start with the original one. You look at the original one and how the original one is transformed into the new one. So original x squared is upward parabola at the origin. This is original x squared. Now this original x squared, the upward parabola we are reflecting about x-axis, it becomes what? Upside down. Let me change them to red. So this is the reflection. Negative x squared. So look at the original one, all you have to do is reflect, it becomes negative. The cubic function is a little bit tricky. The original cubic has this shape. X cube. So its right side is going up, left side is going down. Can you guess what would be its shape if you reflect about the x-axis? The other way around. This part, the upward, will go downward, and this downward will go here, upward. It's like a reflection is like a mirror. When you put a mirror in front of your graph, what do you observe in the mirror? That's the reflection. So the original right side goes on the bottom, and original left side goes on the top. So it gets this shape. It's like they're hugging one another. The black is the original one, and the red is the reflection one. We're reflecting about x-axis. For square root, the original one increases little by little above the x-axis. But when you reflect about the x-axis, so if you put a mirror here, the upward becomes downward below the x-axis. Here. So this is negative square root of x. And lastly, the original absolute value is v at the origin. Now, if you reflect about x, it becomes what? Upside down v. It is negative square root of x. It's always better to draw the original one and then draw your transformation. So in the exam, for drawing the original one, 1 point, and for the transformation, the other points. Okay? So this was our first transformation reflection. We didn't do anything, just put a mirror in the middle, and then we draw the graph, whatever we have. Now, horizontal. It means we have the original function and then a number. For example, here, x cubed and then plus 2. It means it's horizontal. Sorry, not horizontal. Yeah, horizontal. Sorry, my bad. It should be vertical. I made a mistake here. This is not horizontal, this is actually vertical. Vertical. That means the next one is horizontal. Forgot to change. Oh, right. Horizontal. Minus. Okay. So when you see your original graph, our original is x cubed. So our original is x cubed and square root. So we see the original graph and then a number. When you see the original graph and then a number, it's up or down. So plus 2 means which direction you're moving? up 2, and minus 2 means down 2. Now you take the square root function, and you're moving which direction? Up 2, and square root function, you're moving down 2. So when you draw the original x cube is this. It take the original x cube and especially take the origin. Move this origin 2 units up. Move this origin 2 units down. So this point here goes 1 up, 2 up, and you do the exact same graph, but a little bit up here. This is your x cube plus 2. This one you're moving 2 units down. So this origin is 2 units downward, and then you draw the same graph, but here. And the line keeps going on forever. Okay. So you move them vertically on a vertical line. Function plus number means up, function minus number means down. Similarly, for square root function, this is the original square root without any transformation, the parent square root. Now you take the parent square root and go 1, 2 up, and you draw the same square root here. For the bottom, you take it. Fraction means what? You go half units down. You just estimate it. Here, you go 2 units down and draw the same graph. So what you do is you always take the origin, and you shift the origin. So vertical and now the horizontal. Horizontal is the bad one. Bad. It's bad because it doesn't follow the direction. So you have your cube outside the 2. That means the 2 is inside your cubic function. So when you have a number inside the function, you go left, right, opposite direction. So plus 2 means which direction you have to go? To the left. You're supposed to go right because plus is on the right, but you don't. And minus 2, which direction? To the right. So if you get confused, draw your number line. On the left, you have all the negative numbers. On the right, you have the positive numbers. It's bad, but it doesn't follow this format. Here, it goes to the left. Plus supposed to go on the right, but it doesn't. It goes on the left. Minus supposed to go on the left, but it doesn't. It goes on the right. So you're confused, write this down. So you're going to do the same thing. You take the original cube. So this is the original cube. And then you move it to the 2 units left. So you take this origin and go 1 left, 2 left, and then draw the same graph. Same thing here. You take that origin and it says go to the right. So go 1 right, 2 right, and then draw the same graph again. In the final exam, they usually put a cubic graph for transformation. And cubic graph drawing is the hardest one, figuring out the transformation. So you have to remember the shape of the cubic graph specifically the cubic graph and its transformation. My favorite is either absolute value or square function. So this is square root, the original one. You go 1, 2 left here, and do the same square root graph. Here you go 2 units to the right and start your graph from 2. So the black is the original one, of the red are the transformation. So take this, go 2 units to the right, because it's -2. Inside, you square it. And these are the 3 original transformation. And now you're going to do an example. What if we have all 3 together? Then how do you transform them? But before that, does anybody have any questions so far? Any complaint yet? Huh? Great. Let's see. How can we draw them with multiple transformations together? 2 examples. We are taking absolute value graph. We have +2 inside the absolute value, -3 outside the absolute value. And then on G, we also have a negative in the front. So question, this +2 inside your absolute value, which direction is supposed to go? Good job. Inside means left, right, opposite sign. And then you have a -3 after the absolute value. Which direction? After the absolute value. Down. If you have a number after your original function, you have to go up, down. But if you have a number inside the original function, it's left, right. So 2 transformations together, left, right, up, down. This one follows the direction. It goes downward because it's -3 on the y-axis. So this is y, plus up, minus down. But inside, it's left, right, opposite direction. If you have an inside a number, you go opposite direction, left, right. If you have a number outside the original function, you go up, down by following the direction. So outside one is the cool one, the good one, but inside one is the bad one. The way I tell my students to remember is telling them a scenario. For example, when you just start dating someone, like if you like someone, you want them to like you back, right? So you listen to what they tell you. So you're like so cool, so nice to them. If they tell you to do this, you do that. Tell you to do that, you do that. Like you always listen to them because you want them to like you. So it's like the outside one. You just start liking, so you listen everything what they tell you. But once the other person like you back, now you get priority. So you change your style. It's like you become dominant. Like, well, I don't want to listen to you anymore. For example, when you get married, if you look at the married couple, most of the time, not always, most of the time, they don't listen to one another. Like what mom tells the dad, dad doesn't listen. But what dad tells the mom, she doesn't listen. Like in marriage, they don't have that respect anymore. That high respect when you start just liking someone. So once you just start liking, you listen. But once you get inside their heart, means inside the function, you change your style. You don't listen anymore. So we can remember this scenario. You can easily remember when to apply which transformation. Okay. Now we have similar scenario but different numbers. In this case, we have a number in front of your absolute value. Which transformation? reflection. So it becomes whatever the original one. It's reflect about x-axis. Reflection. And then you have a -2 inside your heart. Which direction? Right.
There is minus on the inside going to the right.
Because look at our axis, x-axis. Minus supposed to go on the left side. It's supposed to go on the left, but you don't because it's inside the function. You don't listen anymore.
So what if there was one more -2 for x?
Inside the function, here,
Yeah.
it means you have to reflect about y-axis, but we are not going to do that in this class. If you have a negative sign inside the function, it's x-axis, but if it's inside the function, the negative sign, it's reflect about y-axis. Now we have a single number outside of the function. You just started liking someone. So which direction you're going to go? Up. The single number only goes up or down. Inside goes left, right, opposite direction. And negative in the front reflects. So let's draw these two graphs. You start with the original one, x, y. Do it. All right. X, y. So what's the original, what's the shape of the original square, not square, absolute value function? V. V at the origin. This is the original absolute value. So draw the original one. And then take this original one and then move around depending on the direction it tells us. So here it says, take this origin, go left 2, down 3. So we take this origin, go left 2, 1, 2, 1, 2, and then from that space, go down 3. So down 1, down 2, down 3. Here you stop. And then you draw your absolute value again. For the next one, first you have to start with reflection. So reflection is upside down V. You take this upside down V and you go right 2, up 3. So right 1, right 2. From that position, you go up 1, up 2, up 3, here, and you stop. So the origin goes 2 to the right, and from that right, 1, 2, 3 up, and then you draw your upside down absolute value. Yeah. Okay. Any question? So one of these will be in the exam with all 3 transformation. This. The graph could be different. Graph could be absolute value, square root, or cubic, or square. So from the 4 parents graph I showed you, one of them will be in the final exam, and also one of them will be in class exam. Any question? No? Okay. So you try. The other way around. They give you the original graph and they give you the transformation. Write down your transformation. Which way you went from left to the right.
X -2 parentheses cube.
Y equals parentheses x -2 parentheses cube. Perfect. If you look at the original graph, it's a cubic graph. The origin is here, this is the original one. Now if you compare this origin with that, it goes 2 units to the right. 2 units right, it means it's inside the parentheses, but opposite direction. So right is supposed to be +2, but it doesn't. It has -2. Good job. Any question? So if you're lucky in the final exam, you'll see one of these. Only one transformation. Now I have a few transformations. So go ahead, try them. And if you don't see, let me point them out. This is the original one at 0, and this is here. And this graph, come on. This one is here. So it's this graph using transformation. And then do I have more? No. I'll give you 5 minutes. You don't have to do any math. Just use transformation. You can talk to your neighbors. I forgot the sign-in status. What's the Shahera? I already have so many cubes. Yeah, no problem. Let's see, this is square, this is cube. No, make both of them square. The first one is square root function you're transforming. The second one is square function you're transforming. And these two are cubic function you're transforming. Sign-in sheet behind you. This at the origin. And this 1, 2. You're looking at this one? These are easy. But you can have a conversation with your neighbors just to check whether they're correct or you are correct. Or both are wrong. The inside is opposite.
Yeah.
Because you are already inside the heart, so you don't listen to them anymore. For E and F, this is the original graph. You have to write down the transformation for the next one. For F, the left is what's the graph, you have to write it down. And what is this transformation, you have to write it down. So for F, write both of them. For E, only this is fine. When I write both of them, no problem. Ready? Not yet. Ready? Let's start. A, who would like to help me with A? Volunteer? Go ahead. Which direction we are moving? To right, perfect. And then up 3. Wonderful. So let's draw. Actually, since you're going right, let me draw to the left. So X, Y, the original square root is this one without any transformation, the parent. Now we're shifting this parent, take the origin, go 1, 2, and from that position, go 1, 2, 3 up, and then draw the same graph here. Is there anybody who did not get this? No comments? Too shy? Is there anybody who got this? Great. Now volunteer for B. Reflect to left, down 3. Wonderful. So going left down, so let me draw my axis here. The original absolute value, sorry, not absolute, square root here. First step is reflection. So you reflect, it becomes this weird shape, down. At that reflection, you go 1 left, 2 left, and from that position, 1 down, 2 down, 3 down here. So stop, and then you draw your graph again. The original one, the reflection. Who got B? That these are squares. So volunteer for C. C. Gurkiras, right? The left one, down 2. I actually changed it to square function. So what's the shape of the square function? Parabola. The original parabola is here. Take this parabola, go 1 left, 2 down. 1 left, 1 down, 2 down here. And then draw the parabola again. Why? Reflection. One is inside your heart. One right. Huh? Up to. So parabola, the original one is at the origin. Square. You reflect fast, so it becomes upside down. And take that upside down, 1 right, 2 up. So 1 right, 1 up, 2 up here. And then you draw the new one. Change my square from here. The black one is the original square. You reflect, go 1 right, 1 up, 2 up. 1 right, 2 up. And then draw the reflection of the original one upside down. Question? Comments? Who got this right? Wonderful. And now the other way around. Transformation is given. Give me the equation. Volunteer for this one.
We got y equals parentheses x.
So this is Q and this is?
So I got x minus 4.
X minus 4.
To the third power.
Great. The original one, from the origin, you want 4 units to the right. Right means inside the function. So inside your cube. So you have to go 4 to the left. You want 4 to the right, but you have to write minus. So this is your reflection. Another interesting one, the last one. Good job. I was testing you guys with that. Negative x cubed plus 2. So if you look at this original and that original, they are a reflection of one another. So this is the original x cubed. That means it cannot be only x cubed. It has to be the reflection of that cube. So negative x cubed. And now that negative x cubed, that origin, You want one up, two up. So it's a negative x cubed, and then a plus 2. Any question? Comments? Concern? Complain? Nothing yet? Cool. Not in this class. When you go to the upper level, you will see the Y reflection. Now let me do this. Since I am feeling like I'm teaching a bunch of robots, not human, so I'll give you 10 minutes to be a human. Talk with your neighbors. Make friends with one another. Enjoy this class for 10 minutes today. Feel at ease, okay? And then you're going to start 3.6. Enjoy, not phone, no phones, okay? No phones, just be human being. Talk with one another. Turn around. Make friends. Even if you don't like to be friends with someone else, still try it. Because I want you to enjoy this class. To enjoy, talk, laugh.
Oh, yeah. Bro, my mind is like, yeah, we got like 30. You don't have, you at 30? When you find the pages, bro, yeah, let's go. Found that robot. You actually read? Of course I read. Well, you like, I can like 8 hours on my day. It's like, bro, homework is homework. I know, I did too. And I only did the first 2 questions because I was like, oh, I did all my, like, I was like, everything. You did 1 twist? That was 35. So, that's. Yes. Oh, yeah, he just had it. Our teacher, we haven't even met since today. Did it work today? I don't think we have any. We gotta go to lab back to back. It's not even like a 30-minute gap. We have like, I don't know, this is our worst day. So I'm sorry, yeah. I was so today. Oh, the first one, right? I still holding like, man. Two, I lost the keys. So I left my keys for people. Oh no, 3, I found them on me. I was so mad. I was so I was so excited, yo. Honestly, you have to ask somebody that does it. I need someone. Today's like yeah, no, I'm looking at that. I stare right at now, the same thing we want. Yeah, they already want. I got one great joke. I got it's not like the camera light is like it's way better, but it's way better. I will go to
Yeah, June, no phone. Job, look at them.
Not really. Kind of talks like it was like different. Really bad that like. Yeah, like their first day of school, they had cash. They brought the cash.
Ready? Ready, guys? Yeah. Yeah, did you enjoy yourself for 10 minutes? Did you break the ice yet? No. Not yet? It will take time. Today is only the third day. But I want you to enjoy this class, okay? And I realize you enjoy, or we enjoy, when we have friends, when we can talk, when we feel comfortable. So feel comfortable here. Even if you don't know anything, it's okay. I'm here to help you. Okay? So feel comfortable. Enjoy learning, huh? Good. Me too. I also love math, but easy math. I don't like hard math. Okay, 3.6. Did that at 8.1, 8.2. The due date for 8.1 was tonight, midnight, but I received a couple of emails saying that they still did not have access to my MATLAB. So I'm going to extend only this time 8.1 to next Tuesday. So 8.1, 8.2 definitely due by next Tuesday. Also, their quiz. Quiz number 1 is based on 8.1, 8.2. So one quiz, definitely 2 homework due by next Tuesday. And probably we'll be able to finish 3.6. So you also have 3.6 homework and due date next Tuesday. Okay? So 3.6 talks about properties of function. When you talk about function, first thing we have to learn is relation. Relation is like relationship. Okay? So a relation is a bunch of order pairs. So when you have x and y together in a point format, we call them, they have a relation. They have a relationship. In this relationship, all the x values represent the domain of the function, which are independent, and all the y values represent the range of the function, which are not independent. They depend on the domain. So range is the y values, and domain is the x values. Now, a function, a relation is a function only when there is no repeated x values. So for every one x value, you're supposed to have only one y value. If you have, for one y value, for one x value, if you have 2 y values, then it's not a function. All the x cannot be repeat themselves. Y can be repeated, but x cannot be repeat themselves. So if you look at a bunch of ordered pairs, you look at all the x. If all the x are different from one another, then that relationship represents a function. You don't have to write all the details. The main thing is relation is order pair, domain is the X, range is the Y. Domain is independent, range is dependent. And a relation is a function if there is no X value repeated. These are the things you just have to write. Too small, let me make it bigger. We have 1, 6, 2, 6, 3, 8, 4, 9. A bunch of ordered pairs, so they represent a relation. We have a relation here. Now we have to determine whether this relation represents a function or not. But before that, you have to find its domain and range. So we are going to find what's the domain of this relation, what's the range of this relation, and is it a function or not a function? So domain is what? What did I say? X. So what are the X values you see? 1, 2, 3, 4. And just by observing the domain, you already know the answer for the function. Does this relation represent a function? Yes, because no X values are repeated. No repeated X values. When you don't see the same X value more than once, it's a function. Now for the range, we have 6 twice, but you don't have to write twice because it's the same thing twice. You can write only 6 once, 8, and 9. So domain is the X values. Range is the Y values. We don't care about repeated Y values. As long as X value doesn't repeat, then it's a function. Clear? Now the second example, let me write here. It has 6, 1, 6, 2, 8, 3, and 9, 4. Domain, range, and then whether it's not a function or a function. So what's the domain of this? Mm-hmm. 6, 6, 8, 9. So you already see same 6 more than once. So it tells us whether this relation is a function or not. Is this a function? Not a function. And when you write, you can simply write 6, 8, 9. You don't have to repeat the 6 twice. On my MATLAB, they actually don't want you to repeat. So do not repeat. And now range. What's the range of this relation? 1, 2, 3, 4. These are from your homework. These are too easy, so will not be in the exam. But in the homework, you'll see them. Now the same scenario, but let me highlight the points. You have 4 points plotted on the XY plane. And it says, just determine whether they are function or not. So you have to determine, you need to just see the axis, right? So what's the domain you have for A? -4, -2, -1, and +1. So does A represent a function or not? Yes. Because we didn't see the same x twice. -2, 1, 1, 2. We see same one twice, so it cannot be a function. Not a function. I have space on one line, so I wrote it 2 lines, in 2 lines. But your space, you can just simply write in 1 line. Any question? So, 2 homework questions, we already did together. Let's the next one. What if we are given the graph? Now, just by observing the graph, how do we know whether they represent function or not?
No, the vertical line test.
Vertical line test. It's actually an easy one. All you have to do is draw a vertical line through your graphs anywhere. If that vertical line intersects your graph at more than 1 point, not a function. For example, here, if I draw my vertical line here, how many times the vertical line crosses the 2? Once here and once there. 2 intersection. Is it a function? No. Not a function. The next one. If you draw a vertical line anywhere, I'm drawing here. So I see my vertical line crosses the graph only at 1 point. This is a function. Next. Any idea about the next one? You draw the line anywhere. I'm drawing here. The line intersecting the graph only at once, so it is a function. Any question? In the exam, these are easy ones, right? So I'm going to give you around 6, 7 easy points. 6, 7, 6 to 7. 6 of them or 7 of them. So that you can get not 67, definitely not 67. Around 6 or 7. Okay, now these 4, think about that. I'm going to call volunteers.
We're doing the vertical line.
Okay, go ahead. Volunteer number 1. A. It's a function. You can do the vertical line anywhere. It passes once. Perfect. Next volunteer. It's a function. How do you know? You do the vertical line anywhere and it crosses only once. Go ahead, next one. Yes. You draw, you intersect once. Go ahead. Not a function. Why not? It's already a vertical line. So if you draw a vertical line, it has to be on top of that line. That means two lines are same. So how many intersections you have? Infinitely many intersections. Here, 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 here. They're intersecting everywhere. So it's not a function. So a vertical line cannot be a function. It doesn't follow. It doesn't satisfy the vertical line test. Any question? So we learned if you have a bunch of ordered pairs, how to recognize a function. If you have plotted ordered pair, how to find a function. If you have the graphs given to you, how to determine whether a function or not. And the last thing, what if you are given a function itself? Sorry, what if you are given an equation? By looking at the equation, how do you know which equation is function and which is not a function? So there are two ways, formal way, shortcut way. The formal way says, well, if you have an equation, try to see if you can solve for y. So step one, if you can solve for y, then look at step two. When you solve for y, how many x value you get for one y? Do you get only one x value for one y, or do you get multiple y values for one y? Multiple y values for one x. If you get only one y for each x, it's a function. If you don't get that, it's not a function. For example, when you solve for y equals, let's say, x cubed, it's a function because when x is 0, y is 0, only one number. When x is 1, y is 1, only one number. When x is -1, y is -1, only one number. So for every one number for x, you get only one number for y. So it's a function. But if you have y equals plus minus square root of x, now you have a problem. When x is 1, you get two y values. One is +1 and one is -1. So one x value gives you two y values. It's not a function. You cannot have two y values for one x value. So this is the formal way. Solve for y and see whether you have plus minus sign in the front. If you do have plus minus sign in the front, it's not a function. If you don't have a plus minus sign, it's a function. Now, sometimes solving for y takes time. So instead of solving for y, there is actually a shortcut. Just observe the power on the y. If y has an odd power, then it's a function. For example, here, y has an odd power, it's a function. Y doesn't follow this one. So don't do anything in the equation. In the original equation, if you have a y with the odd power, it's a function. But if you have an even power, or there is no y, even power or no y, two scenario. When y has an even power, it's not a function. Or if you don't see a y, it's not a function.
Plus or minus radical.
You have positive square root of x is this one. You have negative square root of x this one. So if you draw a vertical line, how many times the vertical line intersect the graph? Once here, twice. It's not a function. So the top one is a positive square root of x. The bottom one is a negative square root of x. It's a reflection. So vertical line intersect twice, not a function. So just by observing the power on the y, you can figure out whether they're a function or not. Example. A. What do you think A is? A function or not a function? Why not? What has even power? But what the ruling says. Only look at the y. We don't care about that. So y has to have odd power to be a function. So what's the power on the y here? Invisible one. Is 1 odd or even? 1 is odd. So y has odd power. It's a function. You can verify your work with the graph. How the square graph looks like? Parabola at the origin. So if you do a vertical line test, how many intersections you have? Only 1. So it satisfies, the graph satisfies the vertical line test, and also the equation satisfies the ruling y has odd power. So you can do both ways. Just look at the equation, or if you know the graph, look at the graph. Any question? Do you want to do B, Shahida? Not a function. Why not? Not a function. So it's a vertical line. X equals 8 is this. So obviously it doesn't satisfy vertical line test. Also, what do you observe? There is no y. If you don't have any y, is it a function? No. No y. No y or even y means not a function. Now the last one, volunteer. Why not? Perfect, not a function. Because look at the y. Y has even power. And when you try to solve for y, you are going to get plus minus sign. So you don't get a function here. You don't have to solve anything. Just remember the ruling. Y with add means yes. And besides that, everything else, not a function.
Is there a S or A or O?
Which one?
The Y, 1 power to the 1 equal.
Add, so it's O. 1 is add, so add means function. Here, y has even power, so not a function. The middle one doesn't even have any y. No y, no function. 3 things. Question? So I'm going to give a few of these in the exam. So a few graphing and few of equation. So you can enjoy your exam. There will be some easy questions. The next thing is function notation. So we only seen this before. When you have f of x, it means we have a function in terms of x, where x is the independent variable. So f of x means x is a function, no, f is a function of x, but this f of x, it means we are dealing with the y value. So y and f of x, they represent the same thing, they are the y values. When do you use them? When you simply have a y, you don't know whether you have a function or not. But when you do have f of x, it's telling you that you do have a function, and that function is in terms of x. So how do you know whether something is a function or not? By observing the scenario. What is given to you, y or f of x? When f of x is given, it's definitely a function. When y is given, you have to test yourself. Do you have a function or you don't have a function? Okay. So to make our life easier, mathematician says you don't have to do that always. When you see f of x, automatically assume you're dealing with the function. But they're the same thing, the y values. Now evaluating a function, you replace it x with whatever number they give you and simplify. For example, this one. They're telling us we have a function f of x, and our function is 10x squared plus 4x minus 1. Function. Function. It's a function without even testing. I know it's a function because my left side said f of x. It means f is a function. The equation you have, it's a function. And now it says, well, find the y value of this function when your x value is negative 2/5. So what's the y when x is negative 2/5? Basically, this is what they're saying. Find f of negative 2/5. Means replace every x you see in your function with the x value negative 2/5. And then you simplify using algebra. So we have 10x squared minus 4x minus 1. But we're not going to write x anymore because they told us our x. What is our x? Negative 2/5. So every time you replace your x, use parentheses. You're not going to make mistake if you do that. But if you don't put parentheses, you're going to make mistake. Any questions so far? Okay. Now we go to PEMDAS. PEMDAS is do what? The multiplication first or the exponent first? Exponent. That means we are going to leave our 10 alone. We cannot do anything with 10, so leave it alone. Now work with the exponent. You have negative 2/5 squared. It is how many times you have negative 2/5? Twice. So if you have negative twice, it turns into what? Positive. If you have 2 twice, it turns into what? 4. And if you have 5 twice, it becomes 5 times 5. 25. So it's positive 4/. Why did I write 10? Come on. 25. Because twice means multiplying. Same thing. Twice. So 2 square is 4. 5 square is 25. And negative square is positive. And then we can do multiplication here. You can do 40/25, but you can also do a shortcut. You can cancel the 25 and 10. By what number you can divide also 10, divide 10 and also 25? 5. So 5 goes to 10 how many times? Twice. 5 goes to 25 how many times? 5. So if you divide, your life becomes easier. You get 2 for 10 and 5. What is this? Instead of 25. So you can multiply, no problem. But if you clear them up at the beginning, then you can multiply the smaller numbers. You have 4 and 2. So when you multiply, you get 8. And what is the denominator? 5. So simplify, you get a smaller number. Now let's get to the second number. We have negative 4 times negative 2/5. This time we cannot cancel 4 and 5 because they are not divisible by anything. So we multiply negative 4 and negative 2. We have no choice. So you get positive 8/5. So we bring it down. And lastly, we have negative 1 alone. So you simply bring negative 1. Oh, I made a mistake. This is positive, so it has to be positive. That means, what is this sign? Negative. And see, look back, 8/5, 8/5, but actually they cancel out. This is positive, this is negative. We have nothing to do. We cancel them. So what's the answer? Negative. So if you don't cancel, then you end up with 40/25 minus 8/5. And then you'll see, oh, I have to find LCD. I have to combine the numerator. You have to simplify. It takes longer. But if you simplify at the beginning, at the end, your life becomes easier. Question? Okay. Now we are going to do the same thing, but this year we're going to do something a little bit different. It says I'm giving you a function f of x. And this f of x is x squared plus 1. So we have a parabola, we're shifting 1 unit up. Now they're saying, well, take your parabola and find what is f of x plus h and subtract your function from there. That means we have to do 3 things here. So 2 things here. 1, figure out what is that. What is f of x plus h? Once you figure that out, then you're going to do the subtraction. You're going to subtract your original function from that result. So this is part 2. So we are going to find f of x plus h. So every x you see, you replace that with x plus h. So we have x squared plus 1. But instead of x squared plus 1, you have to write x plus h, whole thing squared plus 1. So you replaced, but you cannot leave them alone. You have to expand. So how many times do you have x plus h? If the power is squared? Twice. So x plus h times x plus h. And then you have your plus 1. So how do you multiply binomials? Well, so this time that, what do you get? X squared. And then you do xh. And then let me change the color. You go the other way. Another xh. And lastly, you have h squared. And then you have your plus 1. Do you see any like terms here? C squared. So these are like terms. So how many xh? 2. 2xh plus h squared plus 1. So this is our part 1. And now we are going to subtract the original function, the f of x, from there. So second part is, let me change the color. F of x plus h minus f of x. It means take the entire f of x plus h and subtract the original f of x. So we have x squared plus 2xh plus h squared plus 1. That's the entire f of x plus h. And you're going to subtract what? X squared plus 1, but it has to be inside the parentheses. Because you're subtracting more than 1 term. Anytime you subtract more than 1 term, you have to put a parenthesis. Why? What happens when you subtract this? The sign change. So the plus turn into minus. this turn into minus. So you have x squared plus 2xh plus 8 squared plus 1, and then minus x squared minus 1. Can we cancel anything? What can you cancel? X squared. So plus x squared minus x squared. Plus 1 minus 1. What is left? 2xh plus 8 squared. So that's your answer. If you don't see, let me write it bigger. 2xh plus 8 squared. So instead of having a number like the left page, they didn't give us a number, they gave us variables to work with. But we are going to do the same thing. Step 1, replace, and then simplify. Once you simplify, they are asking to subtract the function now, the original one, from whatever you just got. So when you subtract, we have to change the sign of whatever you're subtracting, and we get cancellation and the result. This was actually one of the final exams, so you may see this in the final exam. Any question? Let's see what's next. We have another function. F of x equals this. What type of function is this? So how the graph will look like? How the graph will look like? V, and the shifting is? Right to not up. Inside your function means left, right. So it's right to the absolute value function. But we're not graphing here. They want us to find these three things. What is f of -2? What is f of 0? And what is f of 7? Now, you remember your absolute value, right? What do you observe about of the y values? All the y values are here, positive. So for it doesn't matter what x value you plug in, the y must be positive. This is the characteristic for absolute value function. It doesn't have any y value unless it's some type of shifting. So here we have left-hand shifting, we don't get any y value negative. If it's up-down shifting, then we might get negative y value. So what we do, we replace every x you see with the number they give you. The first one says our x is -2, so you put -2 minus 2. What is -2 minus 2? -4. Now, you cannot stop here because you have to pull out your absolute value. When you pull out your absolute value, what's the result we get? +4. Do you know why? Because absolute value tells us the distance from 0. They're asking how much is the distance from 0 to -4. So how much is the distance from 0 to -4? 4 units to positive. Distance can never be negative. That's why absolute value solution doesn't give you any negative answer unless you have a negative in the front. If you have a negative in the front, then you can get a negative sign. Otherwise, the result for absolute value inside, it always has to be positive. Second scenario, we have 0 minus 2. We have -2, but without the absolute value, the answer is +2. Because -2 inside the absolute value means how much is the distance between 0 to -2. 2 units. Finally, the last one. We have 7 minus 2. The answer is 5. And this is already positive. So for absolute value, you cannot leave the absolute value inside, absolute value alone. You have to pull out the absolute value and write the final answer without the absolute value. If you leave it aside here, you're going to lose points. For my method, they're not going to accept that you're going to get 0. Question? Now domain and range again. Domain represent what? And range represents? So in a function or in a graph, to find the domain, you observe what is the smallest x value to what is the largest x value. That's the domain for that graph. If they ask you to find the range, you look at the y values. What's the smallest y value to what's the largest y value? And you put them as an interval notation. When you write the interval notation, there are 2 scenarios. If your graph as a whole, then in interval notation, we have parentheses. But if your graph doesn't have a hole, it's closed circle or a line, then it will be a bracket. If you have a hole in the graph, your count will be parentheses. If you have a closed circle, visible closed circle, but there is a line, closed circle is not visible, just a line, then it's bracket. But you observe the smallest x to the largest x for domain, from the smallest y to the largest y for the range. Now let's see one example. You have a v, that v is going on forever and ever and ever. So in this function, what is your smallest x value? The line is going on forever. So here, this keeps going on and on and on and on and on. The smallest x we don't see, it's somewhere here, negative infinity. So your domain starts from negative infinity on the left. Because it keeps going on forever. So on the left, going on and on and on and on and on. You go outside the Baruch, it's going on. You go more other places, it's going on and on. So do you see smallest x in your function? No. But we do know what the smallest number on the left side we have on the number line? Negative infinity. So that's why on the left you have negative infinity. And infinity always get parentheses. Because it's not a number. We don't see something, just infinity. Parentheses. Same story is happening on the right side. The line is going on forever and ever and ever and ever. So we have the largest number on the x-axis is positive infinity. So get a parenthesis. The domain, the smallest x value to the largest x value. We don't see the smallest x value, but the smallest x, positive infinity. We don't see the largest x, just positive infinity. Now the range. Range is the y. Two. Is it 2? It's actually not 2. When it's 2, do you have any graph?
Sorry,
It's 3. But you're close. Good.
I thought it was clear.
It's okay. So we do see a smallest y value for y. It's here. We don't have any y value below 3. The smallest y value has to be 3. And at 3, we see a visible closed circle. It has to be a bracket. So bracket 2, and the line going on forever and ever and ever and ever upward. To infinity. Three. Sorry, my bad. See your brain? He told me 2. My brain got stuck. 2. But then I said actually 3. So smallest y is 3. The largest y we don't see because the line is moving upward forever. So infinity. Infinity always get parentheses. We don't see that. But you don't see or you don't use, it's infinity. Can you see infinity in the graph? So when you don't see, it's parentheses. Okay, 1 more. 2 more. Let's do this way. Here. Domain is what? X. So what is your smallest x value? Negative 30. What is your largest x value? So a domain is negative to positive infinity. And what is its range? Y, right? What's the y value you see here? 3. Do you see any other y value up or down? Only one number. When you have one number to deal with, we don't use parentheses or bracket. We use a different thing. We call them curly brackets. It's in the keyboard. If you see on the keyboard, it's next. It's the same tab, same button as the square one. So for one number, it represents a set. For set, we use curly bracket. The curly here, it looks like curly here, right? So they call them curly brackets.
Like curly bracket.
Like curly here.
Oh, curly.
So curly here represents curly brackets. And dot, close dot represents square. Any question? Now the last one. Is it a continuous graph? No. It has one piece here. We suddenly jump down and then it goes up. But from up, it suddenly jump down again and then it keeps going on down forever. So it's not a continuous function. Since it's not a continuous function, we are going to have a different domain for different pieces. Look at this piece. In this piece, what is the smallest x value? Negative 50. So this has negative infinity until x value. Here, what is it x value? 0. But what is happening at 0? It doesn't have any closed circle, right? So what you're supposed to have here? Parentheses. And then you look at the second piece. In this second piece, what is the smallest x value you see? 0. And what is the largest x value you see? 1. And they both have which end? Bracket. So union 0 to 1. Union means plus. And then we look at the third piece. So our smallest x is 1 here. We get parenthesis 1 because it's open circle. And then this piece is going on and on and on and forever. So what is the largest x? Positive. The right side gets positive. Infinity. Now observe what is happening. From negative infinity to 0, you get, but then you start your journey again exactly at 0, and then you go exactly at 1, right? And then you start your journey again from 1 to positive infinity. So this is what is happening, right? From negative infinity to 1 So negative infinity to 0, you have, but you start journey exactly at 0, go to 1 and stop. But then you start exactly at 1 and then you keep going on forever. So how much of the x interval, how much is the x-axis you are using here? From what to what? Negative infinity to positive infinity. Even though you have a break, but because where you stop, you start at the same point, you don't have any gap. So here it looks like we have a gap, but at the end, we don't have a gap. So our final domain is actually negative to positive infinity. What's in the range? Real quick. Range is the y, so start from the bottom part. What is the smallest y here? Negative infinity until you reach negative 1. So negative infinity to negative 1, and at negative 1 you have open circle. Then you jump. So you're not starting at negative 1, you jump, and where do you start? 0. So union 0 with a close bracket, and then you keep going on and on and on until 3 brackets. And then you jump again. So you skip 1 and then you start your journey at 4. And then do you go above 4?
No.
No. The curly bracket 4. So can you combine this journey? We cannot, right? Because we have a gap from negative 1 to 0. We didn't start where you stopped, like x. You choose to have some gap, so you cannot combine these two. Same thing here. You start at negative 3, started at 4, so you cannot combine them. So this has to be 3 pieces, but domains becomes 1 piece. So, I should give you a quiz. Next quiz will be based on domain. No, domain will be too hard for you. Function. Decide whether something is a function or not. It too. It's okay. Sorry, we're not supposed to handshake with guys.
Oh, really?
Yeah, our religion.
I didn't know.
It's okay. That's why I said it's okay. Sorry about that. তুমি যদি ডিসাইড করো তুমি বাদ দিবা তাহলে কিনে লাভ কি?